Hello, grade 10s. I love that there's a bit of messiness up here from the previous work. Just feel, anyway. So, the general equation of a straight line. Well, the standard form of any straight line function is, well, hopefully you've got it's y equals mx plus c. So let's just go plus c. So we've got it, lovely little colors, right? So this m here, what is m? Well, m is gradient, and obviously for gradient, we said we used m because gradient starts with m. Cool, and c is, I'm sure you went, okay, c is the y-intercept, and, well, I can't be sure, but what I can be vaguely sure is that I'm sure you said it's the y-intercept. Strictly speaking, I like to rather think of it as c is the y value of the y-intercept. In other words, our y-intercept, oh, I don't know what happened there, is 0, c. It's the y value of the y-intercept. Because the y-intercept, yeah, I guess, is c. Okay, so notice I say a straight line function can be written in this form. This green line is a function, this purple line or pinky purple one isn't. So let's look at two special cases before we can dive into a couple of examples. So let's start with this horizontal line. So horizontal going across, and horizontals, well, the y value is the same all the time. So in this case, we could write this equation as y equals, well, there it is, 4 is hiding underneath there, so y equals 4. Now, of course, you did this with your asymptotes quite a lot, saying, well, the asymptote was y equals 4 for, say, a hyperbola. That would have been y equals 1 over x plus 4. You know, it's moved up by 4. Or an exponential. Okay, so there we go. Y equals 4, so e.g. y equals 4. What about this vertical line? In fact, before we get to the vertical line, this green horizontal line, what is the gradient of this line? Well, the gradient, we never go up. So as we're going along, we go along, we never go up. I must some stage get my skills up so I could have myself running on here. Wouldn't that be great? Okay, maybe during the holidays I can do fun things like that. Okay, so gradient is 0. So let's just look at it and say, yes, we could write it as y equals 4, but couldn't we write it in the standard form? Y equals 0x plus 4. There's our gradient, 0. So 0x plus 4, yeah, that's perfectly fine, but we're going to simplify that 0x because 0 times anything is 0. So in other words, y equals 4. It can be simplified to y equals 4. But there's what it would look like in kind of standard form. Okay, for our vertical line, this pinky purple line going up and down. X is the same number. No matter where you look, x is always the same number. X is always the same number. So what's the equation for this line? X equals minus 3 for this one, because x is always minus 3. There's no way of writing it in this form. What's the gradient of this vertical line? And as I asked the question, I know that we kind of touched on this earlier, but inadequately actually. We went through it quickly. That was probably that Friday afternoon lesson. So what's the gradient of this pinky purple line? Well, it's like it's going infinitely steep or infinitely down. So is it positive infinity, negative infinity? Not quite clear. We never run, so if gradients rise over run, so our gradient we say is undefined. It's not defined what the gradient is. It doesn't make sense in some ways of what it is. Okay, so there are two kind of special cases. Now let's run through determining the equation of a straight line when we're given 2 points. Now, the approach that's written here, and remember, even though that puzzle pauses for you, you can always click pause if you need to get this down, and this is in our workbook. Determine m, substitute a point. Okay, so let's do that. What's the standard form of any straight line function? Cool, so y equals mx plus c. There's our starting point. We're not given c. Remember in grade 9 when it was like, cool, you're given C and then life was dandy. Well, not quite now. Got a bit more work. So let's determine m first. So m is, well, could have said lots of things here. Some of you might have answered what gradient turns out to be. Some would have said rise over run. Rise over run. We were working this out in the previous question. So I like to start with the run. How far are we running? Let's go from this point to this point. So from -1 to 1. I'm going to jump to how I was doing it before and going from -1 to 1, we're running by 2. How do we get there? We said 1 minus -1, 1 point minus the other. And for our rise, we're going from 3 to 2. So we're going -1. Let's do it the other method and say, well, I must go this point minus this point. 2 minus 3. So we're consistent. Notice, and I talked about this before, there's the 1 point, 1, 2, 1, 2. And the second point, we need to subtract the second point. So the second point, we're going minus that is -1, 3. Just to double check that we've got them, we haven't mixed them around. And in the other format, as I was saying, the idea of, well, we're going from this point to this point. Okay, anyway, -1/2 is our gradient. So our equation now looks like y equals -1/2 x plus c. Then substitute a point to determine c. So what do you get as your value of c now? Yeah, well, let's see if we get the same one. As a matter of interest, which point did you substitute? Did you substitute, let's call that point A, and let's call the second one point B. Did you substitute point A or point B? Okay, really does not matter. I'm going to go for A because they're both positive. I could maybe have asked, why would you choose one over the other? Well, yeah, I'm going to go for A. So the y value is 2. So I'm going to replace that with a 2. Then we're going to say equals -1/2. What's the value of x? Well, the value of x is 1. So let's put a 1 in there. And we need a plus c. Okay, -1/2 times 1. So 2 equals -1/2 plus c. Add a half to both sides. So in my bad strategy here, I've got 2.5 equals c. Cool, sub it back in. It said determine the equation, so let's finish it all off. Y equals -1/2 x plus 2.5. And there it is. I always like to see, is there a way that we can just check that our answer is right? Well, if we wanted to, we could substitute 1 in and see if we get 2. And we could substitute -1 in and see if we get 3. Let's try -1. That would be -1/2 times -1 is +1/2. +1/2 plus 2.5 does give you 3. So you can check it by substituting other. Not necessary though. I wouldn't say it's worthwhile spending the time to do that. But hey, if you're looking for extra things to do. Right. This question is going to be a similar idea. So I might put together an explanation so it's in our PDF, but not in this video. Okay, so exercise 6. Let's practice a few. So we're going to do, actually just going to stick with 2. If you want to do more, go for it. But yeah, do these 2. There's probably a website somewhere that for one of the previous questions, I found a calculator online that you could punch these in, not these ones, but the gradient or one of those, you could substitute the 2 points and it would give you the answer. So it's a nice way just to check your work because we don't have full solutions for these. But yeah, if you find one of those, please post it, share it, not to do anything but to check if you got the right answer. Okay, exercise, the next one. Determine the equation of a straight line given a single point. Now, because this is so similar, we're continuing in the same video to do this. And I'm just feeling on a roll this Tuesday evening. Aren't you feeling on a roll? Okay. And yeah, I'll put the mic up here today. I don't know why, it just feels like. Okay. Determine the equation of the line parallel to y equals 2x minus 3 and passing through the point 4, 1. What's the standard form of any straight line function? Y equals mx plus c. By saying that this line is parallel to this line, so it's parallel to this line given, what does that immediately tell us? Well, hoping that you're saying, therefore, this m is 2. So therefore this m over here is also 2. So y equals 2x plus c. Cool, substitute the other point in. and we should be a for away, so c equals 8 minus 7, y equals 2x minus 7. Let's just check it. 8 minus 7 is 1. Cool. So I'm going through the substitution quickly because that's what we did before. Okay, so parallel, gradient's the same. This one, determine the equation of the line that is perpendicular to this line. Okay, what's your strategy on this one? And just type up what your strategy is going to be to solve this. Okay, very interested to see what you say there. And I've been enjoying reading these types of questions, not just what's the gradient and then you write 2. Cool, I'm glad that you're on track, but I'd really like those types of, pause, think, what are you going to try and do? My strategy, not necessarily the only strategy, would be, well, I like equations when they're in this form. Y equals mx plus c. So let's rearrange this one so that it looks like this. Now, why would I want to do that? Well, hopefully I'm not going to ask you the question as a question like this because you either covered this in how you're going to tackle it or not. If it's perpendicular, then we know that they're gradients. So let's call this line 1 and the line we're trying to find line 2. Then the gradients, when you multiply them, are minus 1. It's worthwhile actually just writing that down. It's probably what you're thinking. So just jot it down so that I can go, oh, cool, I'm going to see, I can I was going to put a tick, but the tick is more just to see, cool, I can see that you're on the right track, the right method, during the exercises and any assessments. Okay, cool, so y equals mx plus c, so for this line here, let's do this one in green, line 1. So for line 1, we've got 2y equals minus 5x plus 10. Divide everything by 2. Y equals minus 5 over 2 plus 5. Remember, divide the entire side by 2. Okay, so for the line we're interested in, which is line 2, our gradient is 2 over 5. How do we get this so quickly? Instead of trying to solve some long equation, negative reciprocal. So the first one was, I'm pointing it on screen. The first one was negative, so it's going to become positive. And then the reciprocal, so we're going to turn it around. Gotta have some fun, eh? So there we go. So m2 is that, so therefore y equals 2 over 5 x plus c. And what do we seem to enjoy doing? Substitute. So let's substitute this point in. So the y value is 3 equals 2 over 5 x plus c. If you don't feel like doing this in your head, calculator is there if you want it. Where's my calculator? There it is. So if you want, you can go, oh, well, I don't know how to work these things. 2 over 5. I'm slower on the calculator, I find, for these types of things. Minus 2. I would have seen that, to be honest, this cancels. So I would have gone, 5 minus 5. So that's minus 2. 3 equals minus 2 plus c. But hey, use the calculator, why not? It's there. I'm going to get rid of mine. Goodbye. And therefore plus 2, 5 equals c. The equation, let's go in blue, we're in blue. Y equals 2 over 5 x plus 5. If we substitute that in, minus 2 plus 5 is 3. Okay, that seems reasonable. Cool. So there we are. That's how we do those. We want to do some from exercise 7. So we got one that's parallel, one that is perpendicular, and no, sorry. I wanted to do parallel, yes. Perpendicular, where you've got a little bit of work to do. That was the idea, sorry. I'm not going to give you this one yet, but this is what we're going to do next. We're going to do this one as part of our consolidation. You've already watched this Ed puzzle. We how many minutes in? Probably quite far. Oh wow, 15 minutes plus all the time we answered the questions. But this is like a lesson. So that's plenty for you to do. And then quadrilaterals, that's it. Well done. Please keep it up. For the journals I've read so far, great to see you engaging in that reflection process. That's the purpose of it. And goodbye.